Hi, this is Mr. Merrill, and we're going to take a look at an example involving average and instantaneous velocity and speed. I have some definitions here on the left, a position versus time graph in the middle, and some questions on the right that we're going to try to answer. The first question is, what is the velocity at 11 seconds? So 11 seconds is right about here on the time axis because each tick is 2 seconds. So to answer this question, we essentially need to find the slope of at this point here. So to find the slope at that point there, we just need to find the slope of this line segment. Because in a linear relationship, the slope anywhere on this line segment is the same. So pick 2 points. I'm going to pick this one here and this one here to calculate the slope. Remember, we don't want to do rise over run. We want to be looking at the actual points so that we're not confused by the scale. So here, if I look at the actual points, I have 10 seconds and 5 meters. That's the first point and the top one. And this point here I could say is 12 seconds and negative 15 meters. So then I can use the slope formula. So it would be negative 15 minus 5 meters is negative 20 meters. And then 12 seconds minus 10 seconds, that's 2 seconds. So simplifying that, we find that the slope of that line, this line segment here, is negative 10 meters per second. So if that's the slope of the whole line segment, that is also the slope at 11 seconds. It's also the slope at 11.2 seconds. It's everywhere along that line segment. So let's move on to the next question. It says, what is the speed at 11 seconds? Well, remember, the speed is just the magnitude of the velocity. So here's the velocity. The magnitude of that velocity is just ignoring the direction. In the case of one-dimensional motion, the direction is tied up with what the sign is. So if the velocity is negative 10 meters per second, the speed is simply 10 meters per second. So you just calculate the slope and then ignore any signs. It says, what is the average velocity from 0 to 20 seconds? Okay, so to find the average velocity, that's our definition here. Okay, so it's the displacement over the time interval. So the time interval is 20 seconds, the difference between 0 and 20. And the displacement, we have to look on the graph. Okay, so here's our position at 0. Here's our position at 20. So if displacement is the latter position minus the initial position, that's going to be 20 meters minus 15 meters. So our displacement is positive 5 meters. It means we moved 5 meters in the positive direction. So let me erase that. Again, our time interval is 20 seconds. So calculating the average velocity, we do 5 meters divided by 20 seconds. We find that the average velocity is 0.25 meters per second. Okay, and then we get to what is typically the most difficult problem for students is average speed. Here's our definition for average speed. It says to find the path length and then divide by the time interval. Well, the time interval is still 20 seconds because we're running from 0 to 20. But how do I find the path length? This is difficult for students because you really have to understand the motion, like what it's actually doing. You can't simply look at it as a graph in itself. So here we're starting at 15. Then we're going to the right, or we're going in the negative direction, I should say, because this is a negative slope, until we hit negative 10. So to find the path length, I'm going to look at the path lengths in each of these little sections. So here I'm going 25 meters. I'm moving 25 meters in the negative direction, but path length doesn't care which direction you were going. And then here I'm going, let's see, going 15 meters because I started at negative 10, then I headed in the positive direction until I hit 5, so I had to move 15 meters. And then I was not moving for a little bit, I was just kind of sitting at 5 meters for a couple seconds, so that's not going to contribute anything to our path length. And then I went from 5 meters to right here to negative 15 meters, that's another 20 meters of path length. And then once I was here at negative 15, I went all the way in the positive direction until I hit 20. That's another 35 meters of path length. So adding all this up, so this would be 40, 60, so 95. So even though my displacement was only 5 meters, my actual path length was 95 meters because it counts all the there and back motion. And then the time interval is 20 seconds, so your average speed, would be 95 meters divided by 20 seconds. Let me get my calculator. And that would be 4.75 meters per second. Okay? So the difficulty is really getting the path length, and we do that by just kind of dissecting this motion into chunks and thinking about, okay, how much would I have to move to go from there to there, how much would I have to move to go from there to there. It just takes some practice. Okay, next I'm going to look at the similar type of problem, but now the motion is displayed as a motion diagram. The first thing that I really want to do is look at my time interval, realize that motion diagrams by default begin at 0 seconds. So if this is 0 seconds, then each dot is separated by a 1 second time interval. This would be 1 second, this would be 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay? Now it says, what is the average speed from 2 to 10 seconds? Remember what our definition of average speed was. Our definition of average speed is defining that length, the path length divided by the time. So the interval of time is pretty easy. It's just the time difference between 2 seconds and 10 seconds. So that's 8 seconds. But the path length is something that we have to think about. So here we are at 2. And then I really have to follow this motion to think about the path length. So if I started here at 2 seconds, and in fact I'm at 3 meters here, so I could do this 1 meter, 2 meters, 3 meters, 4 meters. So I start out here at 3 meters, I move an additional 1 meter there to get to here, then I don't move for a few seconds, and then I move 2 meters there, and then I don't move for a few seconds, and then I move 2 meters more until I get to my 10-second dot. So my total path length is 5 meters, and my time interval is 8 seconds. So my average speed was 0.625 meters per second. Okay? So hopefully you understood the logic of where I was getting that from. If I wanted the displacement, I could do a similar type of thing where I know my final position, my initial position, it's simply calculated. For instantaneous velocity, I think this is kind of tricky. So let me erase some of this. For instantaneous velocity, we have to have kind of a realization of what it means for constant velocity motion. Okay, so here's our 10-second mark, and I essentially want to find out what the velocity is here. Now, in truth, there's no way to directly get at it, but I can realize that something about this motion. For a given chunk of constant velocity motion, like I'm just zooming in from this 9 second to 11-second interval. For a given chunk of that constant velocity motion, my velocity at every point in time has to be the same as my average velocity from here to here. It's like as if I'd ask you to average the number of 3, 3, and 3. You don't have to do a calculation to average the same thing. It's just 3. So this is like me asking you, what's the average of the velocity at every point in time, knowing that the velocity is the same. There's really no need to do that. So what am I getting at? I'm saying if you can calculate an average velocity for this time interval of 9 seconds to 11 seconds, then you know the instantaneous velocity at every part of that time interval, because it has to be the same, because this is constant velocity motion. So take some time, make sure that makes sense to you. It's not an easy concept, but it's essentially saying if you're moving at a constant velocity, then your velocity at every point in time is the same as your average velocity over that interval. So what is the instantaneous velocity at 10 seconds? Well, I can get at it by saying, okay, from here to here, what was my average velocity? I had a displacement of 4 meters in what took 2 seconds. So my average velocity in this interval was 2 meters per second, so my instantaneous velocity had to be 2 meters per second. That's probably the most difficult one we saw in these examples. So think about that. If you have any questions, give me an email. Okay, hopefully that helped.